My name is Fabio, and this is another video for my students and for anyone who wants to learn a little more about programming in C language. In the next few minutes, I want to talk to you about the concept of array or vector. Saying array or vector it's the same thing, while I will solving 5 example exercises. So let's use the help of Gemini to help us in the definition of this concept, in this array concept. An array is a fundamental data structure that allows you to store a collection of items of the same data type under a single name. These items are called elements and can be accessed and manipulated individually using an index. So every array can only have one data type. Okay, it can be an integer or a floating number or a character, whatever. It should have a size. That size determines the number of elements it can hold. It's fixed and at the time of that declaration. Okay, you need to specify the number of elements in advance. It uses a contiguous memory allocation. So in the memory, in RAM memory, the values are contiguous in the allocation of memory, and each value is accessed using the index. Each element in the array has a unique identifier called an index. Starts with 0. You can access individual elements using their index within square brackets. Okay, for example, array 0 refers to the first element, array 1 refers to the second element, and so on. Here we are declaring an array with size 5, an integer array, so it can hold 5 elements of 5 integer elements. Here we are storing in the position 0 of that array that is called numbers the value 10. Position 1 we are storing the value 20, 30, 40 and 50. Okay, so here we are storing 5 values in each position of this array. To access one element, we just have to put the value that is within the brackets and then store it in, for example, store it in this variable. So let's go and solve the exercises. First exercise, we need to write a program that asks the user for 5 integer numbers and store them in numbers array. The program must add all odd numbers and all even numbers, also indicated how many odd and even numbers were entered. Okay, let's go. So we have our C file. First of all, we need to include our basic library, so a standard input-output library. Okay, so we can use input and output functions. We have our main function. Okay, and that function should return 0 value. Okay, for each exercise I will use one procedure. So for the exercise number 1 I will develop the procedure exercise 1. Okay, and that procedure will be called in main function. Okay, it will be called just like this. So first of all, I will need to declare one macro. Okay, so this macro will define the value of the size of the array. Okay, so I will call it size and I will put 5. Okay, so this will be the value, the size of that array. Okay, the array, it's called numbers, so int numbers, and it will store 5 values. Okay, so the value that is given to this macro here, it is replaced in here. So this is an array of 5 numbers. After this, I will need to fill in this array. So I will have to ask the user for 5 values. How can I do that? With a loop for. Okay, it will start with 0. it will end in size and I++. Okay, here I need to ask the user for a value, so insert one value, and then I will have to store this value with using a scanf, and this will save in the position, okay, of that array. So in the first iteration, this loop will get the number 0. So first I will store the value that the user inserted in the position 0 of that array. In the second iteration, I will store in the position 1, and so on until the position 4, because this array has size 5. Okay, after this array is filled, so we can, for example, define a procedure that will show that the values of that array, I will call it show array. This procedure will receive two arguments. The first of all will be an integer array. I will call it nums. Okay, the argument does not have to have the same name that the function here. So here I will have to put size. Okay, it will have to have two arguments. The first one is the array, and the second one is the size of that array. Now, to show the value of the array, I will need to go through all the array, and this size here I have to put it here. Okay, and now for each position, for each repetition, we just have to printf %d. I will put a vertical bar here, and now just show the value here. Okay, before the printf we could put /n, and after the printf we could add another /n. Okay, so we have a good format for the showing of that array. Okay, now if I want to show the values that the user inserted in this array, I just have to call for this procedure. How? Show array is the name of that procedure, and here I will put the name of my array, and here I have to put the size of that array. So this way I am first of all asking the user for values, and this way I am showing the values that are inside of that array. After that, I have to sum all odd numbers and even numbers, and I have to count how many even and odd numbers exist in that array. So for that I will have to go through all the array again. Okay, but first of all I will need to declare four variables. First, sum odd, okay, to sum all odd numbers. Sum even, okay, int count odds, int count even. Okay, now inside of this loop I have to check how can I see if a number is an even number. It should be divisible by 2. Okay, if numbers I, okay, here I am getting the numbers. How can I see if a number is divisible by 2? Just seeing the rest, okay, and if it's equal to 0, so it is divisible by 2, so it is an even number. Okay, else it's an odd number. Here we have to sum even numbers, so I have to sum these values here, okay, for each one, and every time that we enter here we just have to count one more even number. Here we do the same thing, but for the odd numbers. and count odd plus plus. Okay, that way we are summing all the odd and even numbers, and we are counting all the odd and even numbers inside of that array. And last, we have to show those values. So printf exists %d even numbers and its sum is %d again. So for the first %d is how many, so count even, and the second %d is the sum even. Okay, and in the final of that sentence we have to give it /n to change line, and we can do the same thing to the odd numbers. Here it's counts odd and sum odd. Okay, so the procedure is called here in main. So let's see how it works. We are using GCC compiler. Okay, this file it's called arrays.c. We are creating an output. I will call it ARR. So let's see what is the problem here. So we are count even plus plus here. It is giving me an error here. Why? Let's see. Here I wrote it with a D instead of a T. Okay, let's compile again. Okay, let's run. Okay, insert one value, 1, 3, and 5, and then 2 and 6. Okay, 1, 3, 5, 2, 6. So correct. 2 even numbers, 2 and 6, and its sum is 8. 3 odd numbers, and its sum is 9. Okay, all correct. So let's do the exercise number 2. Write a program which asks the user for 5 characters and store them in the character array. Okay, then you should ask for another character to check if it exists on the original array. It must indicate whether the introduced character exists, and if so, how many times it exists. Okay, let's do the exercise number 2. I will write another procedure. I will call it exercise 2. Okay, in this case we are using a characters array, so it's a char characters. Here the size, I will use it again, this macro that was defined here. Okay, now we have to fill in this array. We can use the same thing that we used in the exercise number 1, but now we are not storing integers, we are storing characters, so we have to use %c. Okay, insert one character or one letter. Okay, and this way we are filling in all this array with all the characters that we want. So we are working with characters, so to guarantee that we are not storing the enter key of the keywords, we have to flush the memory. So after the scanfs, we have to do this instruction here, so we can clear the memory of the keywords, the memory that stores the key enter. Okay, the keyword, the enter key. Okay, so you just need to use this instruction when you are working with characters specifically. Okay, now we have to ask for another character, char letter, and printf inserts the letter to look for. Okay, and now scanf %c letter. Okay, now flush again because we are working with characters. Okay, now we have the 5 characters and we have the another character, and now we have to check if it exists in that array. To check that, we have to look inside of all the positions of the array. So to do that, we need to go through all the array and check if in that position, characters I, if it's equal to letter. If it's equal, so that if this condition is true, we know that the letter exists inside of that array. So what do we need to do then? We need to see how many times it exists. To see how many times it exists, we need to declare one variable. I can call it a counter. Okay, it starts with a 0 because here we know that the letter does not exist yet. So when this is true, counter plus plus. Okay, so when we arrive to line 57 in the end of this loop, we know how many times that letter exists inside of that array. If counter it's bigger to 0, we know that that letter exists inside of that array. Else, put s, the letter does not exist in the array. Okay, if that is true, we can write a printf, the letter %c exists %d times in the array. Okay, so for %c we will put the letter, and %d we put counter. Okay, in that way we can see how many times that letter exists inside of that array. So let's test the program. Okay, it's exercise 2. Okay, now let's compile. Now let's run. Okay, insert one letter. I will put A, B, A, C, D, and I want to look for the letter B. It exists one time inside of that array. Okay, I can run it again. A, B, B, D, D. I will look for D. The letter D exists two times in that array. Okay, it's running okay. A, C, D, A, E. I will look for K. The letter does not exist in the array. Okay, all functioning correctly. So let's see, change the previous program to indicate in which position the character exists. So we have to know in which positions the character exists. It will be in here, because if this condition is true, the letter exists in the position of this I value, okay, because the variable I indicates the position inside of that array. So here we can put printf, the letter exists in the position %d/n, and here we put I. Okay, the letter exists in the position 0, the letter exists in position 1, and so on and so on and so on. So let's see, we can compile it again. Okay, run A, B, B, C, A. Insert the letter we are looking for, letter A. So the letter A exists in position 0, the letter A exists in the position 4, and the letter A exists two times in the side of that array. So it's all correct. So let's go to the exercise number 3. Write a program that initializes a vector or an array, it's the same thing, called numbers with the following elements. All of this. It's 10 elements that are here. The program should find and display the largest and the second largest elements of the vector. Okay, let's do another procedure. Okay, I will call it in main function. Here we have to declare the array. Okay, what will be the name of that array? It is called number. Okay, that vector is called numbers. Okay, the values that will be stored inside of that array is 2, 6, 32, let's see, 32, 76, 1, 7, 76, 1, 7, I think it's 4, 9, 1, 7, 4, 9, 21, and 10. 21 and 10. So this is another syntax to declare an array, but all correct. Okay, this array will have the size 10, and 2 will be in the index 0, 6 will be in the index 1, and so on and so on, and 10 will be in the index 9. Okay, now what we have to do, we need to find and display the largest and the second largest elements of this vector. So to do that, we need to declare two variables, int larger, okay, int larger 2, okay, second larger, I will write it like this. Okay, we can say that the larger is in the first position. Okay, this we know that this is not true, but it's a form, a way that we can compare this position to all the others. So now we have to go through all the array, but as we know that the first position is already taken, okay, we just need to go to the second position, and this array has size 10, so we can put 10 here and I++. Okay, here we are going through all that array. So if numbers I is bigger than larger, okay, what we know, this condition is true. We know that we found a number that is bigger than the larger that we have here before. So if that is true, larger 2 becomes larger, okay, and the new larger is numbers I. Okay, larger 2 gets the value of larger, and the new larger will be numbers I. And when we arrive to the end of this loop, we have the larger and the second larger. Now we just have to show it. Printf larger 2 points %d/n. Here we put larger, and second larger, here we put larger 2. Okay, the procedure has been called in main, so we just have to test it. So compiling and test it. Larger is 76 and the second larger is 32. 76 and 32. Okay, now we just can see, if I put 74, the larger will be 76 and the second larger 74. Let's check. Okay, it's not working. It's not working. Why? Why? Because this is not true. Okay. Else, if numbers I it's bigger than larger 2, okay, larger 2 is numbers I. Okay, because here we are just checking if it's the bigger one, but if it's not the bigger one, it could be the second bigger one. Okay, so we do this. So let's see now if it's correctly. Okay, 76 and 74. Now it's done correctly. Okay, now let's see the exercise number 4. Develop a program that generates 10 random numbers between 1 and 100 into an array of integers. Then show the entered values and then invert the vector. Okay, so I have in my channel a video that explains subprograms and subroutines, and how to generate random numbers is explained in that video. So here we are just going to generate random numbers. To do that, first of all, we need to include two libraries, standard_lib.h and time. Include time.h. Okay, we need that to generate random numbers. Now I will write procedure 4. Okay, it's here. Now what we have to do, we need to give it a seed to generate numbers to using the clock of the computer. Okay, and now we have to get the array. The array is size 10. Okay, so I will define here a new size. Define size to 10. Okay, so here int what is the name? The name we don't have names, so I will put random numbers. It is the name of that array, and the size 2. Okay, and so this array will be size 10 and it's called random numbers. Now I have to fill in all this array. So to fill in, I have to go through all the positions in that array and then generate random numbers for each position. So random numbers, I, it's equal to rand percentage 100, and this will generate a random number between 0 and 99, but I want to generate random numbers between 1 and 100. To do that, I just need to add 1 in the end. So here we are generating random numbers between 1 and 100. Okay? Then we have to show those values. To show those values, we just need to call this function. We will give it the name of this array. Random numbers will be sent to this array here, and size 2 will be sent to this size here, and now we are showing the original array. So printf original array 2 points, okay, /n, and then in this way we are showing the original array. Now what we have to do, we have to invert that vector. To invert that vector, we need to create another vector, random numbers inverted. Okay, and the size will have to be the same. And now what we have to do, we need to do another loop. Okay, I will do a loop that is a bit different from what we have done until now. It starts with I will declare another value that starts with size 2 minus 1, and then it will have to repeat the same time that before, so 10, I plus plus, and j minus minus. So I will control the second array and j will control the original array. Why I'm doing this? Because we want to the original array needs to start with 9 and the second array needs to start with the first position. So here we are storing in the position 0 the value of the position 9 in the original array. So I goes to 1 and j goes to 8. So in the position 1 we are storing the position 8. In the position 2 we are storing the position 7, and so on until the end of that array. After that we just need to show the inverted array. So inverted array, and here we send the inverted array. Okay, we are just calling the exercise 4 here and now compiling and test it. Okay, original array 46, 17, 46, okay, and it ends with 64 and 8. 8, 64, and it ends with 17 and 46. Okay, all correct. The last exercise, develop a program that asks the user to enter max integers, so the size will be max, and stores them in a vector of integers. Then construct another vector that stores in the I values the accumulated between I and I minus 1. Okay, the number of elements in the vector must be defined by the max constant. Okay, so original vector is 1, 5, 8, 10, and 7, and 1, it's 1, but 1 plus 5 is 6, 1 plus 5 plus 8, it's 14, 1 plus 5 plus 8 plus 10 is 24, and okay, and plus 7 it will be 31. Okay, we are adding the accumulated numbers and storing in the second array. So let's do that in exercise number 4. So the last procedure, void exercise 5. Okay, we are calling it. So we need to declare one new array, int nums. Okay, we need to declare another macro that is called max. I will say that the max will have size 5. Okay, it's just an example. Max here. Okay, we are declaring one array that has max size, and now we have to fill in this array. We can use this example here. It's the same of the first exercise because we want to fill in that array, but now we are not using max, and the name of that array is nums. Okay, insert one value and storing that value. Okay, now we can show that array, show array, we send nums and we send max. Okay, now we are showing the original array. So printf original array 2./n. Now we are showing the original array. Now what we have to do, we have to accumulate. To do that, we need another vector. So nums AC for accumulated and max. Okay. Now we have to go through all the original array. How can we do that? Another time with a loop. Okay. And for each position, we have to start the accumulated array with the value 0. So because in the beginning, this array must have 0 in every single position, so we can accumulate that position with the values in the original array. Okay, to accumulate, we need to go through all the positions. We are using the j variable, okay, and we need to go through all the positions until we get the position I. So if I is 2, we need to go to 0, 1, and 2. Okay, and then we have to sum all of that positions and add them in the accumulated array. Okay, so nums AC, position I, we are accumulating, so plus and equal, and we are putting those values in J. Okay, we are summing the value that is in 0, 1, and 2, and we are storing the sum of that accumulated values in the second array. Okay, we do this for all the positions in the original array. Now we just have to show the accumulated array. And here we just have to show the new array. Okay, all correct. We are calling exercise 5, and then we have to test it. Okay, we have an error here. Let's see. Nums AC, we are here in the position 0. Okay, it's the C that could not be in caps lock. Okay, compiling again and then running. Let's use the values that are in this example. So 1, 5, 8, 10, and 7. So 1, 5, 8, 10, 7, 1, 6, 14, 24, 31. Okay, all correct. I hope those 5 exercises gives you several examples on how to declare and use and look for and search and go through all the positions in the array. I hope this video was very helpful. If you have any doubt, leave it on the comments. Take care and goodbye.